On the grand scale of time, humans have only existed for a moment. Our civilizations, built up over thousands of years, amount to nothing but a blink in the eye of time. Long before our ancestors erected the first stones of our first monuments, the Earth was ruled by strange and unfamiliar life forms in wild, untamed landscapes. As we stare down into the dizzying depths of prehistory, the years blur into incomprehensible numbers. 575 million years ago, the first multicellular animals rose from the primordial mud, the precursors to every animal that has ever lived. 3.9 billion years ago, the first single-celled organisms received the spark of life, never knowing that they would indelibly affect the future of the entire solar system. 13.8 billion years ago, the universe was born. These extreme lengths of time defy comprehension, but they aren't simply the result of guesswork. Geochronology is a multi-field discipline that combines paleontology, geology, and chemistry to provide accurate, mathematically supported timeframes for events in deep time. The systems scientists use to construct a timeline of prehistory are jaw-droppingly precise. By wood and bone, rock and soil, humanity has gained an unprecedented view into the deep past. The application of geochronology has allowed humanity to peer back into those far-off days, long before mankind came to dominate the world. Geochronology achieves its accurate dates by utilizing methods of absolute dating. At its simplest, methods of absolute dating identify the linear rate of decay in certain elements and organic compounds, and use math to wind back the clock to ascertain the time when decomposition began. Using these methods allows a chronology of rock layers to be identified. Then, if there are objects within a rock layer that can't be dated, geochronologists can assign estimated dates to them based on the positioning of younger, older, or contemporary rock layers. This is known as relative dating. There are multiple different methods of absolute dating, and the usage of any particular methods are dependent on the type and condition of the material being tested, as well as the location the material was found. Some methods can be more susceptible to external modifiers, but often multiple methods of absolute dating can be used in order to verify both systems and doubly confirm the age of the material being tested. In this way, absolute dating is always being verified, cross-referenced, and calibrated to ensure a high degree of accuracy. Across the temperate latitudes of the Earth, vast forests cover the land, and the rings of their innumerable trees can provide a timeline of ancient history that is precise to within a year's time. These natural calendars are the core of dendrochronology. Dendrochronology as a science has been developed and refined for over a century, and is supported by thousands of tree ring samples across 6 continents. The rings of trees, living and dead, can reveal details about the local climates as well as identifying the precise age of ancient archaeological sites stretching back thousands of years. The wide variation of seasonal temperatures in temperate climates provides the biological impetus for tree ring formation. Tree rings are read from the center outwards, and one ring consists of a light band and a dark band. The light band represents spring and summer growth, when temperature is favorable and liquid water is plentiful. In the cool fall and frigid winter, a thin dark band forms as a signifier of unfavorable conditions, completing the ring. If a spring or summer were defined by a drought, the lighter tree ring in that year would be thinner, and inversely, if a spring or summer were particularly rainy, the ring would be even thicker than normal. If a drought ravaged a forest one summer, a 1,000-year-old tree and a 4,000-year-old tree would display a similar ring pattern that season. As the trees grow, the 1,000-year-old tree would show the drought ring closer to the center than the 3,000-year-old tree. Long after both trees are dead, a dendrochronologist can determine that the trees were 3,000 years apart in age based on the positioning of the drought ring relative to the total rings on each tree. A tree might go through dozens of different stressors throughout its life, and those stressors tell a story that can be compared to other trees of any age. If all the trees are telling the same story, then a timeline can be established of the oldest to the youngest trees. This results in a master chronology, a local history of the climate that could stretch back thousands of years. In order to more easily store tree ring data, a skeleton plot can be created to chart only the traumatic rings from across the life of a tree. The y-axis of a skeleton plot tracks the age of the rings, and the x-axis charts the size of the ring. The narrower the tree ring, the longer the corresponding line on the skeleton plot, and inversely, wider tree rings merit shorter lines. This simple method is an easy way to clearly see when in its life a tree suffered trauma, and skeleton plots can be compared to identify trees that are either younger or older in age. Dendrochronology has one flaw, and that it is not totally viable outside of the temperate zones of the Earth. Unlike temperate trees that have a punctuated period of dormancy in the winter, trees in tropical or desert climates typically grow at the same rate year-round. This means that desert or jungle trees do not consistently produce a tree ring every year. As many as 50% of the tree rings in tropical trees can be considered false rings, which can't be used to accurately gauge the age of a tree. Some species of desert trees don't produce rings at all. This means dendrochronology is mostly viable as a method of absolute dating in the temperate latitudes, and cannot be used with the same efficacy in regions without a defined warm and cold season. All trees have a chance to produce a false ring, or not produce a ring at all, but false ring production in deciduous and evergreen trees is relatively rare. In the temperate latitudes, false rings in multiple similarly aged trees can sometimes be signals of extreme climate events in a particular year. These false rings don't invalidate the given ages of these trees, they can actually serve to reinforce the timeline, much in the way a historical drought or wildfire would. Additionally, false rings have a unique cell structure that is identifiable under a microscope. Even if a tree is missing rings or produce too many, the formation of those rings is fundamentally different from the norm. When and why false rings might be produced, and what conditions affect the expected rate of false ring production, are well-documented phenomenon. Therefore, the existence of false rings does not invalidate the dates given for individual trees or lengthy chronologies. A wealth of tree ring data is held in the International Tree Ring Databank, a collection of over 5,000 datasets from across the world, with 9,000 publicly available tree ring samples. Other databases, like the Swiss Federal Institute for Forest, Snow, and Landscape Research, list 14,000 core samples taken from 600 different sites and 40 different species of trees across the Northern Hemisphere. These and other repositories have allowed scientists to study ancient climate and archaeology in the distant past. The oldest wooden structure dated with dendrochronology is a buried well discovered in the Czech Republic in 2018. By comparing the rings and the tree species used in the well's construction with existing tree ring chronologies for those species, researchers were able to determine that the trees were cut down 7,280 years ago. And in California, an incredibly long-lived tree called the bristlecone pine was used to create a master chronology that extends back over 8,800 years. Dendrochronology isn't guesswork. It's a legitimate field of science built up over decades of global effort. The accuracy of tree ring dating is undeniable. Even the proposed flaws of dendrochronology are explainable. False rings portray themselves under the lens of a microscope, and their existence helps bolster the validity of the science. With the help of trees, we have an incredible view of the Earth's climate across millennia, and the extreme events that shaped the lives of our distant ancestors. The more information we can learn about the ancient past, the better we can predict the future of the Earth's climate in an ever-changing world dominated by Homo sapiens. Thank you for watching. I hope this video was enjoyable and informative. I strongly encourage any feedback you may have. If there are any aspects of dendrochronology that I missed, if you believe I got something wrong, or if you want a dedicated video discussing the arguments against the validity of dendrochronology, please let me know. Also, please consider liking and subscribing, and read my channel posts for information on future videos.